Hey everybody, as promised, here is my video since we're pretty much at the cusp of the New York release talking about probed pattern migrations. If you went to Knowledge 19, I did this as a lab and a breakout session, kind of both all in one, to help folks understand what to look forward to when this time had come. I'm going to go through a lot of this, pretty much the same things, some limited. But if you went to K19, you've seen the show, but we're actually going to do it for real with the knowledge articles and the scripts and everything else here. So hang tight and let's have some fun talking about what probes to patterns are all about and what you have to plan for. Obviously, I got this slide in there because we have attorneys now, and it's important for you to read things like this. All right, what we're going to talk about today. We're going to talk about the journey we've taken from probes, from discovery in the beginning, and where we're going with patterns. Talking about the transition, moving over, what the architecture is, and the migration process, because there's a lot more moving parts here that you may not be familiar with if you've just been doing discovery with probes and sensors. And then we're going to look at the structure behind the scenes, some of the things you need to keep a lookout for. And I'm not going to do this last part, but I will provide a link to extending patterns. It's a fun little piece lab that everybody has done before if you've been through training, but I did it at K19 just to give folks a good practice in understanding how they can make patterns more of their own, but you could do that on your own. All right, so talking about probes and sensors, we know and love them. Those of us who have tattoos that say probes and sensors for life will always be fond of them. They allowed discovery to be modular and extensible. It allowed us to, if the customer wanted something very specific that did not come out of box, you could easily, if you could find the right query, you can easily create a new probe and write some JavaScript within the sensor and get that data into the CMDB form. Probes and sensors also, as they were born, gave us those magical four phases we all know and love. The port scanning, the classification, identification, exploration. Made life really easy to troubleshoot and such. It also gave us important data into the CMD, which was the whole goal, right? Let folks know not only about the computers and piece of network gear and virtual worlds that they had, but also built relationships, really critical relationships that made the CMDB very relevant. As I like to call discovery's relationship building, it was always kind of two-dimensional. And it was really good, but it was always looking for something a little bit more. And one quick fun fact as we leave the probes and sensors is ECCQ that I shared at K19. ECCQ, that those three letters, never had an original meaning. It was just a quick keystroke that was going to be changed at a later date and never did until I think it was Matt French in marketing and back in the early days got tired of being asked the question, what does ECC stand for? So it magically became the External Communications Channel. But while your friends at the pub trivia next week, when you tell them, hey, ECC really didn't have an original meaning. All right, about 2014, ServiceNow acquired a company called Nebula, a really powerful startup out of Israel. And they were filling that important gap in that service-centric, as you can read with me in the screenshot, view of services that are built within the CMDB. It was no longer a two-dimensional relationship, as in this Microsoft SQL instance runs on this server and it's used by this .NET application. It actually went from the top down, as many of you may already know and love from our service mapping products. It was really powerful, allowed us to tie really everything in the CMDB that was focused on a particular service to give folks that important insight that they needed to do that service mapping. Somewhere around Instable release, I guess the powers that be said, hey, we got to go to one format, I guess if you want to call it, about the tool, and they were going that the pattern base was the path they wanted to take. It was a good thing. I like patterns. Sometimes I do miss the probes and sensors, but I think patterns are really powerful, and it makes it a lot more user-friendly, I think, in a lot of ways. You don't have to know that much JavaScript, but we're going to see a lot of different ways you can still use your JavaScript prowess to do some magical things within pattern-based discovery. And it also helped us ensure that we provide a consistent tool set. You've got some folks doing service mapping, you got other folks doing horizontal discovery. Horizontal discovery folks talk probes and sensors. The service mapping folks were talking patterns. Now they're going to be talking the same language. It's important to understand that probes and sensors are not going anywhere. We still need them. They still need to do the Shazam port scan phase. We still need to do the classification phase. We still have other probes that patterns can't yet accomplish, such as our installed software or our application dependency mapping. It's important to know the technology supported to run probes and sensors will still be supported. It's just that any new development that ServiceNow comes out with for product-wise will all be pattern-based. So that's something to look forward to. And the main thing I love here is our out-of-band releases. If you haven't already been following, you can see on the community store in that every quarter we're pushing out new patterns that you can download to your instance without having to wait for another full upgrades. You can imagine 5 years ago, ServiceNow is now discovering coffee makers, for example. Now I have to wait for the next release to get that coffee maker discovery. Now, as we build those patterns and they can be supported by your version of the instance, and ServiceNow comes out with that coffee maker pattern, for example, you could just download that pattern and not have to wait for the whole upgrade process. So really powerful add that we have, and really helps get new features into the hands of our friends out there even quicker. Patterns are cool because you can see what they're doing, right? All in one particular view. You don't have to do a lot of scripting. A lot of it's drag and drop. A lot of it's pretty straightforward and pulling in data, then being able to manipulate it through graphical interfaces instead of having to define some magical JavaScript combination in a sensor to utilize. So it's really user friendly and it's very powerful. It is extensible, right? You can add your own capabilities. You can manipulate the data the way you want. You can add your own queries. It utilizes shared libraries, as we'll take a look at the actual patterns. But as you see, Windows hardware information, there's a library, a group of steps that is shared across other Windows types of OSs. Not dissimilar to what we did with our own probes and sensors, right? Windows OS information probe, for example. That was shared by all the server classes and the computer class. Same thing with libraries. One key difference, though, is that these patterns are all mid-server based, where in the past we would kick off a discovery and a probe would be picked up by the mid server, asked the question, and returned back to the instance for the sensor to process it. The pattern runs completely on the mid server, completes everything, and then returns the payload back to ServiceNow. So we're going to talk about mid-server requirements that you may need to increase somewhat, but just understand that everything happens on the mid-server now for the most part in the processing and collecting of data. We also have really strong pre and post processing scripts that we're going to take a deep dive into that really help extend the functionality. Patterns utilize the entire identification and reconciliation engine. I'm going to get very deep into that because it's very important. The IRE is even more critical when it comes to patterns and understanding what's happening there. Okay. Now here's our migration lab. One thing why we need to do this, people are wondering why all the deal with having to mess with a migration path to probes, from probes and sensors to patterns, was because patterns do a lot more, in a sense, in relating CIs and building relationships. In probe and sensor days, we would find a serial number, create the serial number, reference it to a computer, and be done with it. Now the pattern, when it builds references and relationships, it actually looks for those relationships inside the IRE. So you want to be sure that those are built and identified, which helps give you a really solid CMDB. No longer you're going to be filled up with all these serial numbers, or they're just orphaned and left behind and such. Now the IRE is saying, wait a minute, if you want a reference to this computer, I better see that reference or I'm going to create it. And that was where the problem was. You couldn't just turn on patterns and say, hey, let's look at what I have. because we would have created duplicates. Patterns would have, while they would have seen that serial number, for example, in the serial number table that's referenced to a computer, it did not have that relationship built. So it would say, okay, I need to create my own here. So it's really important why we're doing this process and building these references and relationships. One, to keep your CMDB in a much cleaner order, and two, because the patterns really require it. And as you see, do not switch until you've gone through this process. All right, so as I just said, we add the appropriate relationships and references, so to make sure that we don't create duplicates. And then what these scripts also do is it changes all your classification records, such as the Win 2012 classifier, Linux classifier, all the things you're familiar with, and it disables all the out-of-box probes and actually enables your horizontal patterns. So it takes care of the relationships and changes everything over to patterns for you. It's a really cool tool that a friend of ours, Chris Thompson in development out of San Diego, did all this great work, and I'm very proud to be able to represent his good work and the overall team's good work in having this video. Now, some of the things you need to look out for. You have to be on the New York release. There's a lot of script improvements, and there were a lot of PRBs, well, not a lot, 12, that were fixed that really addresses some broken pieces that really sets you up for success. If you went to K19, there was talk of backporting, but there is no longer any talk of backporting. You got to be on New York to be able to execute these scripts and move over to the newer pattern technology. And then you also want to go through and check that you see that you have a horizontal pattern in your different classifiers. Here's Windows 2008 as an example. But the good news is that we actually have a script that's going to help check all these things out for you and be sure that everything's good to go for the migration. Alright, so here you want to review these KB articles, 94477 and 50351. I'm going to put this in a community article, obviously, and I'll also provide links to those. It is optional to work with support. I'm a fan of giving them a call, opening an incident, saying I'm going to go through this process. For experienced discovery administrators and even moderately experienced discovery administrators, Chris has made this almost near seamless to run this migration process. And as you see as I demo it, but if you just want to be sure, you have your incident open with support, anything comes into trouble, you got someone there, you've got a record, and you can keep track of it and go and find out what's going on. So always, as anything, start with your lower level environments, your development, your test, make sure everything's working as you design. And you'll read in the KBs, for larger CMDBs, you absolutely want to run this through a scheduled job. We're going to run it in background scripts today, and you can if you've got a really lightweight CMDB and it's really not collecting too much. But if you have hundreds of thousands of computers and such in your CMDB, you're going to want to do this through a scheduled job, because the platform does a much better job of working the tasks through the scheduler than it is through background script. And then also check to see if you have created any custom probes, that maybe patterns already do that work for you. Your custom probes will still work. They will just, as you can read along with me, they will just be run after the pattern runs. Or maybe you have a great opportunity to get your hands dirty into patterns and take your custom probe work and include it into your own pattern, or extend existing patterns to collect that information. And I've done some videos also in the community about extending and creating a pattern from scratch, so keep a lookout for those. I'll most likely put a link to it in the community article as well. Alright, so here's what we're going to do. We're going to execute a discovery on my mid server so we could see probes and sensors, make sure everything came in okay. We're going to execute the required update scripts, and of course, again, discover the system and see the magical pattern take place. And we're going to pause the PowerPoint boredom right there. I'm going to kick over to my instance. Welcome to my instance, and what I'm going to show you is real quick is I have discovered my CI already with probes and sensors. So I've just discovered the mid server, Everything looks like it always has to us. Everything's running. Got a great device. Got my CI. There's my Windows server. Looks beautiful. Got my serial numbers, running processes, network adapters. Again, if I were to just turn on patterns, I would get duplicate network adapters, duplicate serial numbers, duplicate memory modules, because all those are built into the pattern with references and relationships. So now, first thing we want to do is I'm going to pull up our KB, and again, I'll have links about it, and it goes through and talks about, and it's very well documented, I think, is understanding what they need to do and how they're doing what they do. So one of the things that Chris built for us is a script include called Probed Patterns Prerequisite script that will do a lot of those checks for you, which is really cool. That's part of a different KB, and that one's over here. And that's just an update set that I've already preloaded, but you'll have access to this as well. And I'm going to run this script and this XML script, and what that does, it goes through and does all my prerequisite checks. So here we're going to do this in scripts background. I'm just going to copy and paste that in and run it. And here we go. So you see everything horizontal, everything passed. This is a brand new instance, so it better darn well pass. But here's that they identify what needs to be converted, what fixed scripts should be run, and then looking at what they needed to do and any checks that he's ran. And of course, if there were any errors, they would be listed here for you to go ahead and resolve and fix those up before you run the actual migration script. So nice little step to do. It's not absolutely required that you need to do this. It's just a really good idea to run this even after your own checks to be sure that everything's in order for you to run the primary update script, which we're going to scroll down here in our KB. And here he talks about whether or not you want to run these individually or run them all together. And also talks about the utilizing scheduled jobs to run this. Again, if you got really large CMDBs, scheduled jobs. If you got a smaller CMDB, and I really don't have numbers for you, but you can run these individually. And you'll be able to see, or in background scripts, not individually. And you'll be able to see, even if you wanted to take those extra steps to go through, hey, I'm going to do my Windows first, see how everything flows and works, and make sure all my Windows servers are fine. These are not interdependent in each other, Unix systems, routers, and switches. You can run your Windows, have a go at discovery, validate everything, give it the thumbs up, and then move on to Unix, validate everything, give it the thumbs up, and move on to routers and so on and so forth. So you have that capability if your process defines that. Not bad, but for our bit here, I'm just going to run it all, right? So one thing I want to give you a look at is here is just so you get a visual reference. So we're going to come down to Windows, and we're going to look at our Windows 2012 server, and because that's what the mid server is, and then we're going to take a look at our triggers probe section. So we see all of my exploration probes are all probes and sensors, and I do have one horizontal pattern, which you should already have in your setup. If you're starting fresh, we've injected these into builds, I think from Orlando. No, it can't be Orlando, 2-3 builds ago, I think. We had started incorporating these patterns into these classifiers, but they were all set to false. So everything looks good there. And I'm going to take that fix missing relations from probes to patterns. I'm going to duplicate this. And we're going to go to scripts background again. Again, smaller CMDBs, use script background. For larger CMDBs, run it as a scheduled job. So away it goes. Here is the magical work. And that's what happened. Obviously, with a lot more data other than just this one computer that I've discovered, it's going to take a little bit longer, obviously. But you can see I got positive results, adding exit interface relationships. It's building all those pieces out to help prevent those duplicates. and then all the classifiers that were reverted. Everything looked great. So now we're going to come back over to our 2012 server, reload that form, and now we see all of my probes are now false for the most part, and my pattern is now true. Now there are other things, as I mentioned in the PowerPoint, application dependency mapping, installed software, those are all still remaining true, as should be your custom probes as well. And now that's all that's going to be triggered when we look at discovery. So what's going to happen is we're going to go through the same discovery process. We're going to classify it, Windows 2012 server. We're going to now do our identification and primary exploration through the pattern, because that's one of the things that the patterns do now. They gather all identification information, they gather all exploration information, and they give it over to the IRE to say, here you go, fill up your CMDB with this computer I've just discovered, or network device, of course. And when this pattern completes, and then these other exploration probes trigger to get this important information, right? So again, if you can continue to write your own probes and sensors, along with the pattern, knowing that it will be executed afterwards. It will continue to work, continue to be supported. However, again, all new development and really focus on support will be at the pattern-based level. Now let's kick off another discovery. Of that same system. And away that goes. So we're going to take a look at that in a minute. But that was our migration. Thank you. Applause. Keep the applause to the end, folks. Joking. That's all it takes to migrate, is running that script, and then having those relationships built, and then having the horizontal patterns enabled, and all the exploration, most of the exploration probes disabled. That was why we had to wait. We needed those important references and relationships to give you a much more solid CMDB for all those ancillary CIs that are related to your primary class CIs. All right. Now, let's talk about where all this stuff is. So, as you get familiar, my discovery friends out there, now you're going to be dealing more in the pattern designer as opposed to just sitting in discovery definition, tweaking with probes and sensors. Patterns come in three primary types. So you'll see you can find your discovery patterns in the pattern designer or that table. And it comes in infrastructure, application for service mapping and application mapping, and shared libraries. So let's talk about infrastructure. That's what you do for your hardware. If you're building a new pattern, you want and it is for hardware, you need to use infrastructure pattern because it does do different processing on the instance side. If you mistakenly make it an application type pattern, start over and you'll be in good shape. Remember, it's the same classification process. There's nothing changes with this. For example, our 2016 server name contains that value. It's going to be a Windows 2016 server. So nothing changes through that. But now instead of triggering those probes as we saw, we now are going to trigger a pattern. Okay? So everything's the same right up to this point. So our application patterns are to explore processes. So us discovery friends out there, we all are very familiar with creating a new process classifier. Here's our Microsoft SQL example. Whether you want to create an application for, Tomcat, it's out of box, or acme.exe application, you follow the same process. Hey, when you see a command that contains SQL Server or a name that contains this or that, create my Microsoft SQL instance and relate it, runs on the computer that I found. Nothing's changed here. You could stop right there in this top section and we'll create it and build the reference and relationship. Now if you want to do more exploration, again, you could still write probes and sensors, but now you can utilize patterns to be able to query that database and get that CI enriched with a lot of good data that the customers or consumers are going to use. It's important to understand my third bullet there. The IRE, the Identification Reconciliation Engine, is now a part of the process classifier. In the past, in the very early days, we remember, it was just a correlation ID, I think Alec called it, between the process and the computer it was referencing or related to. Now the IRE, even for your process classifiers, need an identifier to be able, just like the computers need an identifier, to ensure that we're mapping or updating the correct CI. Again, we're going to talk a lot more about that IRE, but now instead of just creating this process classifier for the brand new Acme application, I now need to also include, a process classifier for the new Acme application. I need an identifier for the Acme application so I could define the rules to make sure that it updates or creates a very specific CI. And of course, we have shared libraries. Shared libraries, as we talked a little bit in the beginning, are steps and actions that are repeatable, so you don't have to rewrite the whole steps 4 times over for the same class of computer. But remember, if you modify any pattern, any out-of-box pattern, without using the extension section or modify a library, you're going to affect every class that library is being called in. So if this CPU and memory is also called in the Windows computer pattern, and I make a change in the Windows Server library, it's going to be affected by the computer. The computer CI class is also going to be affected. So keep that in mind when looking at libraries and such, and you don't want to, and understand the best practice in that. All right, so now let's go take a look at what happens with the pattern. Hopefully you guys got enough out of that. I wish I had the ability to have questions asked, but we'll do that on the community. So let's go back over to our instance, and here's our discovery, and a lot less probes and sensors, a lot less activity for this one device, which also obviously helps speed up discovery a little bit, but it's great information. So we can see, we'll do our created, so we see our port probe went out, our classified probe went out, and then our pattern went, and then once the pattern returned, we triggered those other probes as we talked about before. Now if we go to the discovery log, we see the step for doing the Windows OS servers. Now I really like this. This is kind of cool. I can click there, and now I can see all the steps that were taken to discover this Windows CI. So we're going to take a look at the pattern itself, but step by step I can see things that it's done, such as save this new host name. Maybe it didn't have it. There you go. So here's the host name, right? Get it from the registry, and we could see everything that it's doing, and then any errors that might come out in the bottom. So we see all the relationships that it's building, any references, processing scripts, post-processing. Now what's neat about this is I can go through those step by step, but if I really want to look at it, I'm just going to highlight this discovery section, and I'm going to click debug. Now what that's going to do is, you can follow along, as you see it's going to load into the pattern designer, and then I'm going to get to automatic mid. I only have one mid, and I'm going to allow it to connect. So now I'm in a debug session. So now it's basically ready to do these step by step if I want all the individual queries that I'm building or querying that system about. And what Doug does is I go right down here at the bottom and I let it run. And it's going to go through all the steps and start populating all of our CI information, reference relationships to other tables that might exist. And while we wait for this, let's talk about a little bit more about the makeup of this. So one of the things about a pattern is that we have all the CI attributes that are associated to the Windows Server class. What's cool about this is you can see these keys. These are actually telling you that these are identification pieces. So you need to have one or multiples of these based on your identification rules, so that CI, this Windows Server CI, can be updated or created in the CMDB. So, and here are all your related lists that you're used to seeing as well. So those are all those tabs at the bottom that could be populated. Now those can be found in the SACI to pattern table, and it's important because not only does this show you which pattern's associated, but it's really cool because it allows you now to define the deletion strategy for that related list. So you could see the 4 options that you have here. Hey, if I don't find this file system or this disk as an example, what do you want me to do with it? Should I delete it, keep it, delete the relation, or of course mark as absent? You can make that decision now, but you have to know I have to go over to this table, SACI to pattern table, to be able to set these values. And we just talked about those. Now, so if we look at our pattern now, still working. Again, it's just doing another discovery basically of that target to fill in that information. So where are you at? Oh, you're in the storage section. All right. So here's that list I was talking about, and this little hamburger type-ish menu here. Once this finally finishes, you can actually click on that and add other related lists here, right? Add other related lists here to be able to add values or attributes if you want to collect them for your primary class. And again, we're talking about Windows Server here. And once you do that, we could see all those here. Now, if I added any, I want to come into this table, related CI types, and define my deletion strategy. So as you create new classes, maybe you're creating a whole new pattern and you want to have related tables, I can add them pretty easy just here in my pattern designer, but I need to come into related CI types to define my deletion strategy. I think by default it does a keep, but we'll check that out for sure. And you're still working. Now, another cool thing that we have about these patterns is the pre and post processing scripts. Now, for those of you that love your JavaScript, this is where you can still live and breathe. They actually run a lot of relationship processing and property fetching, and as I have here, name formatting. And you have 3 cases where you can determine them to run. In a pre-execution, I can execute a script that pulls in properties that my pattern may need to know about before it runs. Example, trusted name source, right? As I'm setting the name of my CI in the pattern, I want to know what my trusted name source property is, and it can load those properties for us. If I want to do something with the data pre-IRE, I do it in the pre-sensor pre and post scripts. And then if I want to manipulate or do something with the data after identification, I could do that in a post-sensor script. Now, if you've been following me along in the community, I've got a link to Patrick DiCarlo. Has an amazing post about how these work and different ways to manipulate it. So I'll have a link to that as well, just in case you haven't come across it. But it's a great write-up on using pre and post scripts that I reference all the time, and it's really neat to see. So let's get back over here, and here's our machine. Everything's populated now. You know, this is just what it would look like if I were discovering it. And then again, here are those different tables, and I can't click that because I'm in debug. So we'll look at these other things. Here's all the temporary variables that were collected. Is DNS trusted name sources, right? Is Hyper-V. All kinds of properties and attributes that are preloaded into the system. So we're going to go over here and we're going to look at pre and post processing. So under the pattern designer, pre or post processing. So you can see we've got about 35 here of different types of pre and post processing scripts that come out of box. I've added one here as a part of our lab, but you can see where we do a pre-launch, where it's a pre-execution, and you can see it's actually getting software types for filters, so it knows, hey, what do you want me to ignore? Is managed by the CCM, is trusted, so getting properties, those sorts of things. So you can see that's a good example of a pre-launch pre-processing script. Now, one of the things to take note of is that these are assigned per pattern. So here in this pattern, this will run on Windows OS servers, OS desktops, and a Hyper-V server. So this postscript would not run obviously against a network pattern. So you want to take special note of that. Looking at the one we built for our lab that I'll have a link to, you can do this on your own, is here in my lab we actually set the Windows start time. And if anybody's been to any of our discovery labs over the years, it's a favorite go-to because it makes it easy to understand what I'm doing and how to get it in, and then allows you to really use your imagination and extend it. Now the challenge with that lab was that in our sensor, back when we did it in the sensor, remember, is processed on the instance. So as I got a value back and I needed to do a query against the platform to find out what time it was, I could not do that in a pattern because the pattern runs on the mid server and it finishes and it returns that data. So what do I do with that? So here, as we talk about the Windows OS servers where I've applied that, it's a pre-sensor, so before you go through the IRE, we see it does some pretty cool things. Now, my friend Tal over in Israel helped me with this because I'm a very proud copy-paste scripter. So it takes everything it discovered, all the payload, all the items within the object, and then it sets the variable of main CI to nothing, just to clear it out, I guess. Now, one thing to take note of, discovery scripters out there, is you remember in our sensors, we would set attributes for current dot attribute, right? So the current record I'm dealing with dot start date, for example. That's the attribute I want to fill. In patterns, in this scripting, main CI is now current. Main CI is now that current that you're used to thinking about. So here we just make sure that it is a Windows CI, that the class does extend from CMDB CI computer, a little safety check. And then we take the main CI values dot start date, and then we subtract that from our uptime converted. So now here on the instance, I can do what is my current date and time, subtract the seconds from the lab, if you're familiar with it, or you'll be reviewing it here in a minute, and then refill that value start date with that updated time, so we get that current date and time. So it's it's an example of how to manipulate the data before it goes into the CMDB. And in this case, again, pre-sensor, it's before the IRE gets a hold of it. So really, really powerful piece here. Take your time, look through how all these are working, and it help you generate ideas how you might need to use them at a later date. All right, so now I want to talk about identification and reconciliation. Very, very important. Now, I've done a couple of community posts around the new IRE, but now that it's fully on board and we're all about to go to New York here in a very short period of time, identification is even more important. Now, this is something that you've got to understand, is that we have two sections. If you're not already familiar or have looked at the new identification engine, we have identifier entries and related entries. So these are two key pieces. Identifier entries do the base class identification. It's how identification in our discovery minds has always worked. These are the rules off CMDB CI hardware that you're going to check to find that unique CI or create a new CI within the CMDB. Identifier entries check the base class CI. Related entries are there for the references and relationships that the pattern wants to build. It does not measure base class identification. It's just there to support the pattern when it wants to build its references and relationships. Now, hardware doesn't have them all. Disks have their own identifier. Network gear has a network card, I think, network interface has its own identifier. So you won't see all of them here, They'll be existing though, but just to understand that these related entries support the references and relationships that the pattern wants to build. If you have custom identifiers and you switch over to patterns, you're going to break, and that's what my community post was all about, is that it's not going to be able to build those references and relationships without specific identification entries. So take a look at your identifiers if you've customized them or you've created your own. Say you had a good reason to have a very specific identifier for Windows computers for whatever local reason, and you just have that based on name. Let's go back one or two here. So you just have name, right? And maybe serial number. But you have no related entries in your identifier. You want to use this hardware class identifier as your guide. So you're going to have to add these. Now, as I mentioned in that community post, your computers aren't going to have switch forwarding tables, right? But it's sometimes better just duplicate it, make it perfect, exactly how it wants to be, just so you don't run into any weird problems down the line. But again, okay, it doesn't need switch forwarding table, but it does need serial number, right? In my community post example, a friend had removed the serial number because they didn't like it. It didn't work for them. So when they switched over in a practice run almost, it failed because serial number was not their attribute. By quickly adding it to related entries, everything worked fine. So now as we see, there's also the class manager that you can utilize pieces of the IRE. So we have our identification rules that you'll see has the ability for inclusion rules. But one thing that you will notice as you read the third bullet here, it doesn't have related items. So I have to work in discovery definition identifiers to modify my related items and not be able to do that here in class manager. Now, one of the things that's cool about the class manager does have inclusion rules. Now, inclusion rules I really dig because now it allows the IRE to query the CMDB to help in its decision process on whether or not I should update that CI. Such as the one I have here, if you can read it, sorry for the small print, that if the status is not retired, right? So if in this identification rule, hey, if I'm, say, switching from a piece of hardware to a virtual machine, but I need to keep that hardware in the CMDB, but everything's almost going to be the same, the name, everything else like that, you can utilize this inclusion rule to say, you know what, if you find that Windows server that's retired, but it matches, no, it's retired, create a new one. So it's really, really handy when it comes to managing the CMDB, the different inclusion rules. But again, you don't have inclusion rules in the discovery definition identifiers, just like you don't have related items here in the class CI class manager. So no, you may have to dabble in two different areas of the platform to really tune your identification rules, and one day they're going to bring all under one roof, and I look forward to that. All right, so now let's talk a little bit about mid servers. As we know, we all know and love what mid servers do. They're Java apps that are running in our friends' environments. It does our queries for us. But now with patterns, we know that mid servers run all the patterns for us. At startup, they download all the patterns. So it's not unlike if they were just downloading all the probes and got a query saying run probe 296 Windows OS information. Now it's just run this pattern that you already have available locally. And again, it returns all the payload at once. Now, what some of our PS friends out there have seen, that they are increasing host resources, and do your good due diligence in looking for how your mid servers are performing now with probes and sensors. Look at their CPU and memory consumptions through the dashboard and identify that, hey, I may need to throw a little bit more memory, maybe some more CPU if those are already peaked out. If they're already running fine, less than 50% memory and CPU utilization, then I would say have a go at patterns and then watch, right? After you run your full discoveries with patterns, watch to be sure that, hey, I may need to have more resources or my resources are still on point. but our PS friends are saying this is what they're recommending out there nowadays when you're looking at a large enterprise deployment. So you can use this as a rule of thumb. And then, of course, increase your threads. One thing to know that patterns take one thread. Unlike probes, some probes needed 2 or 3 threads to run. Patterns, one thread. So you're looking at, hey, I can run 100 patterns at once, depending on what you're setting. And then always remember, if you're going to increase a lot of memory, always leave half available memory to the host, so the Windows operating system or operating system in general has enough resources to do what it needs to do to manage our JVM. So keep an eye out for that. Some of the other things that I've done most commonly are changing some mid-server properties, and that's the max payload size. Sometimes you just get so much information back in that pattern that the platform, the mid-server, just kind of can't handle it all. So good news is that we do have max payload size and max pattern payload size for the mid-server, inside mid-server properties now. Now, no, these can be global if you leave them empty, or you can assign these to only one mid-server, but really it's always good to leave them global. But if you do come across those payload issues, these are the properties you can change. Don't change them unless you need to, but know they're available there for you. We all know, if you're not familiar now, capabilities. A lot of folks should be already familiar with capabilities, especially if you've been clustering your mids, but you want to be sure that the mid server and the pattern knows which mid servers have availability to do which tasks. Mid server applications, which applications can call and utilize this mid. Again, hey, I want this mid server to do discovery, while this other one obviously maybe just for cloud management, but you can define those. And then IP allocations. Discovery, this works for us. IP allocations, horizontal discovery does not care about IP allocations. This is primarily there for service mapping. Service mapping for if you've got a environment, say your standard 3-tier environment, where your databases are in a secure zone that you need a special mid server and they're on a special IP. So when the service mapping runs, it knows, oh, only this mid server can get to this IP. Discovery does not care about that. So you define what IP ranges are assigned to what mid server clusters at the schedule level. We don't care too much about this, but we do set them to all. So just take note of that and those little special caveats. All right, so now that's the general bit around the patterns, where those important pieces are that you want to look for, the pre-post processing scripts, the related items, the differences in the IRE, and then we're going to go through, well, we're not going to go through extending patterns, but here what I'm going to show you is I'm going to provide this link. Where are you? This link to developer.service-now.com, and what this does, it goes through just basically what I did, extending the pattern, do the migration, and then extending the pattern to do the OS information. So we see here I'm doing uptime. I'm utilizing the extension section in my pattern, because if I modify this, I now own that whole pattern. But if I add my pieces to the extension section, I can continue to do my customizations and still get primary class updates. And then we go through one method of extending the pattern to do the start date. And then we go through a second method, which does the same thing, but it does it better, only because AM PM isn't a measure. That's a little trick. That's a little hint to why we have two here. But in this case, again, we utilize the pre and post processing scripts to really manipulate our data. So this first one does not do pre and post processing scripts. It's just straight value. And this one, we actually manipulate the value afterwards. So if you want to go through this lab, you're welcome to, just for your practice. I will provide a link to this developer link, I'm repeating myself, so you can go through and see what we did at K19. Again, I think that's it. I do have one other piece about the inside baseball one. This is a good one. Is if you want to duplicate, we all know it's a good practice if you want, back in probes and sensors, to, hey, if you want to do your own Windows OS information probe, to copy the guts of the probe and the sensor and then make it your own, leaving the out of box alone, so you always got those updates and can reference them. Here with patterns, you kind of do the same thing, but you do it all for everything. So if you don't have the ability to do all your good work in the extension section, and you really need your own really truly customizable Windows patterns, but you don't have the time to type out the 348 steps that it takes to discover Windows systems, you can easily copy and paste everything from that pattern. Now, the first thing you want to do is create your own custom pattern, as I have here, custom pattern for Windows services. Create an identification section. In here, I had no steps whatsoever. Saved it. And then when I click on that pattern tab, what you do is you copy this metadata piece. And the most important thing is probably this sysID. Now I take that metadata piece, put it on a clipboard somewhere, put it aside, and then I go to the Windows pattern and I copy and paste all the steps within that pattern. So you'll get the whole lot of what the Windows pattern is. And then I'm come back to my K19, in this example, K19 custom pattern, paste everything back in there. So now your pattern NDL will look like the Windows, but you just replace that one metadata piece that was from the original Windows, save it, and now you have a custom Windows pattern. And when you click into this discovery section, all the natural Windows steps will be there, and you'll be good to go to be able to do the manipulations that you want. Important things, remember, don't forget about shared libraries, pre-post processing scripts. They're going to contain the same shared libraries. If you mess with that Windows OS information library, it's going to change it for all the other patterns that are using it. If you have a custom name for your pattern, you want to apply it to your pre and post processing scripts, just like the other Windows Server pattern did. So keep that in mind. You got a lot of different moving pieces here to be able to do what you want to do when copying an out-of-box pattern. But really, this is the secret key right here, is create your own, including an identification section, grab your metadata, copy and paste the out-of-box pattern from the infrastructure pattern, replace your metadata, and you're good to go. All right, so I hope that was helpful. I'm sure the links will be really handy to have, and support will be there to help you within the tenets of an incident and working you through these KB articles if any questions come up. But as you saw, it's really easy to do. It's just now wrapping your head around, hey, I'm dealing in pattern world now, no longer probes and sensors for the most part. I got to think about all these other pieces. Thanks, and let me know if you have any questions on the community, and we will